fourth presentation of the afternoon is by Karthik Kannan, and the topic is Quantum Informatics for Businesses and Economies.
Thank you. If the decision is based on efficiency, we have the shortest title, right, just in case. All right. I will talk about the KPIs and all of that in a few minutes. What I want to lay out is there are three big changes that are happening in the quantum space. One, last December, which is December 2018, Trump and the Congress have put in place this National Quantum Initiative Act. This is to lay out a plan for the United States to improve on its quantum capabilities. That's point number one from the policy angle. From the technical angle, the quantum computing capabilities are continuously increasing. At the end of this year, we are likely to have about a 128-bit quantum computer being available as well for computational purposes. Now, third, first was the policy piece, second the technology piece, third being the corporate piece. Many companies are investing in quantum computing and capabilities. Be it Microsoft, we know their connection to Purdue. We have Google and Intel and other companies also. It's not just the technology companies, it's companies like Ford, traditional companies that are investing in this. Volkswagen is investing in quantum capabilities. So what we want to point out is it's very timely as to what we are doing here. There's a $1 billion investment that comes out of the National Quantum Initiative Act. NSF is looking for opportunities to fund thoughtful, meaningful centers. Some might be STC, the Science and Technology Center, or university and industry cooperative research collaboration as well. So that's one piece of it from a timeliness standpoint. We have David McInnes, who's enabling collaborations with Purdue and Ford. So we have a number of complementary companies which are in the quantum space that are also looking at quantum capabilities, which we could synergize to take advantage of those investing opportunities that exist. At the end of the day, we need to have the core before we can do anything. We have in the traditional methods such as nonlinear optimization, we have teams, we have improved on the quantum computing capabilities internally at Purdue, as well as we have domains such as defense, healthcare, and others where many of our solutions are applicable. I'll come back to this point again in a few minutes. This is the team that we have. As you can see, this is a very diverse set of teams. I don't have much of a background in quantum. I'm relying on my quantum team to help me get through this research. But as you can see, many of us here are senior professors who have established and who have built a reputation in our individual domain. So it's a coming together of many of these folks as well. Now, as regarding the track record of having worked with prior teams, there are many such collaborations. I won't have all the time to describe exhaustively all the collaborations, but here are some of them. Saber and Andy have papers together, DOE proposals together. I have a research proposal with Ilias. There are many such cycles of interactions that you can think of that are salient for this proposal to go through. Okay? And obviously, when you look at the group of people we are pulling together, it's truly interdisciplinary. We have Ilias, who is an applied math PhD. We have somebody, Andy Jung, who's from physics. Saber Kais is from chemistry. We have engineering represented, science represented. Obviously, I am representing Krannert as well here. Right? So it's a truly interdisciplinary sort of research. And what we want to do is actually two different domains, or two different thrusts, if you will. What we are looking for is quantum optimization. So can we take one of the problems? One of the problems Ilias and I are working on relates to big data analytics, where they need to deal with robust decision making. We are dealing with 200 variables and millions of users, close to even 1 billion users. Okay? And how do we use the data and understand the graph theory behind it? That's the part we are looking at, and that is a problem that could be studied using quantum optimization very, very effectively. Similarly, we have quantum modeling of economy and cognition that's becoming very salient. If you take quantum computing, quantum logic, and apply it to economics and stock market behavior, you're able to see better model or better outcomes that are represented. This is not just me talking about this. Martin Shubik is a very famous economist who has some prior work on this as well. And similarly, you have quantum cognition. How can you use quantum logic to model human behavior? These are very salient and useful as we go in the future. What I'm going to do is, as regards the goals, think about we have two different prongs as we are looking at these goals. One is to get some cycle and momentum going towards STC or the NSF IUCRC effort that is going on. Simultaneously, we are trying to work on some small research projects. The one we are talking about relates to how we could solve this graph structure problem using a D-Wave simulator. We're working on this. We hope to work on this as we look at the goals as well. So our structure is set up such that we are going to try to achieve both of them. Now, this is my last slide. There is plenty of opportunities in both NSF, for NSF STC, and potentially also NSF IUCRC. Many companies, Yang has been talking about this, many companies have shown interest in terms of these collaborations also. And we have a very good set of skills here internally at Purdue. We have people who are very strong in the traditional models, be it nonlinear optimization, be it information theory and all of that. Those people are part of this group. We have quantum computing capabilities that are available. Saber and Andy and Yang have previously worked on similar problems. We are able to bring their resources in. Andy is looked at in the particle physics context, how do we look at complex data analysis? And you have domain expertise. This proposal has been supported by Purdue Quantum Science Engineering Initiative, IDSI, Archie, and I'm representing, this is not a Discovery Park Center, but my BIAC will also be part of this and proposing this work. If I have a minute left, I'm well ahead of time, and so we'll call it quits. Thank you. Andy, do you want to come up? Young, I don't know how your role is, so you're a senior advisor.
So my question really involves, it sounds as if you're describing what your goal is to establish a core here within Purdue as a platform in quantum computing. So my question, and if that's the case, my question is really, as you're engaging the Boeings, the Fords, they're all going to come to the table with very specific problems that they're going to want you to apply your expertise to. How do you envision yourself not becoming diluted with a lot of small projects where you basically are a transactional house that you're doing applied research for them versus you're expanding the frontiers of what quantum computing could do in the future?
Very good question. So Tom, we are already doing something similar with many companies. I mentioned to you about one of the Fortune 100 companies with 200 variables and all of that. What we do is we do translation. A big part of what the center, BIAC Center, does is we take a research problem that is a little bit more applied, frame it a little bit abstractly so that we are pushing the boundary of knowledge, if you will, right? And so essentially we will add value to the company as well, but simultaneously we are thinking about value add overall, right? So that's part of the effort that has to go through. When you look at many of these problems, people are still struggling with even the basic from what I understand.
Yeah, so maybe as a follow-on to that, and maybe some competitive intelligence that you may be able to have garnered, these companies you say are investing in quantum computing capabilities. What do you mean by that? I mean, are they looking to develop their own infrastructure and become the Purdues of the future for themselves, or are they looking at it in a different way?
So I gave you some example in my proposal, in our proposal as well. What we have is, for example, Ford is trying to use quantum research, quantum optimization tools to deal with fleet management. It's a very application domain. And so how do you translate that problem into something that would be of meaningful research? We have to go explore and converse with them to identify the research questions before we can frame it more broadly. So the other issue is when we look at the research what we were doing with that company is not interested in whether you use quantum or any other capabilities. They are looking at robust decision making. And we don't have the current computing capability to do that. We are providing with a framework of that. Thank you. Please, sorry.
Your value proposition was cast two different ways. On the one hand, there was the claim that everybody's doing it and we should be doing it. And with that, I'm kind of a little bit leery. There was Bitcoin a while back. We started with the money, and the money part, let's put it aside. Let's think about the science part.
Absolutely.
And the science part was divided into two big domains. One was the optimization research, and then there was the quantum cognition and all that. Now, with the optimization part, I mean, are you trying to say that you guys will tackle NP hard problems? Is that where we're going with this?
So, Andy, you want to take...
Are we there, and are we there yet?
No,
I want to hear it said yes.
No.
Or no.
No, I wouldn't think that we are there.
Yeah.
No?
Not
Okay,
quite
so
yet.
what is the, so if it's not that ambitious, so what is it that we will tackle that other people cannot tackle?
Well, the idea is to find the implementations for the problems that we have, and those are NP hard, but break them down into something that we may be able to solve.
So we're not at the point where we can solve the problems. We are still working on solutions to solve the problems.
Absolutely.
Okay, all right, fair enough. You know, and that's very important to state, and I want to be clear in my mind what you guys are doing. Yeah, go ahead.
Sorry. You had asked this question. Everybody else is doing it. Are you wanting to do it? No, that's not what we want to say. We are saying that there is significant interest and money that's available. We have internal capabilities. We have capabilities with people who are doing quantum-related stuff. It's taking advantage of the synergies that we exist. And recently, IBM put out a set of partnerships with universities. There are 5 universities. Purdue is not one of them. And it's important for us to be in that space to make sure we are visible in that domain. And it's no fun that if there is $1 billion that is out there, we should be able to get a portion of the pie, and that's Andy.
Again, you know, when you start with the value proposition, I would have expected the science part of it rather than the why, you know. But a second question, what's quantum cognition exactly?
So quantum cognition is how do you model the human's decision making and thinking about this. So classical probability theory is what is most often used in terms of modeling behavior. What they have shown is the ability to use quantum logic to model this. Let me give you a slightly different example to the best that I understand. Okay, so this is why I'm relying on the others to walk me through it. From what we understand, probabilities are often realized only after, or the delay, for example, if you're traveling on a car, the delays are often realized only after you sit in the car. The realization of what state your car is, or is very similar to what state, the realization of what state that quantum turn is. So that sort of a modeling is what, from what little I understand, is that quantum modeling is allowing us to do those.
Okay, thank you.
Okay.
This may be a naive question, but it seems as if you're exploiting the power of quantum computing to solve a set of problems that are out there and seemingly well understood what the problem is.
So even in our case,
Where I'm headed is,
go ahead.
does this quantum computing capability allow you to tackle problems that are not yet well defined? I mean, is it taking you into new domains?
Well, you want to define the problem, of course, but then we might be able to solve, or the hope is that we solve problems that we cannot solve yet with classical
I
techniques,
understand,
right?
and that's the focus of it, but it seems to me that there are lots of people doing that.
So
There's a tremendous amount of interest in quantum computing.
President Jishki, so if I look at how things are, we currently, for this company that we are working, where we have framed this as a different problem, right? The method we are developing is identifying the graph structure underneath the data generation. That, in its current form, is very, very hard to do, even with traditional methods. Forget about quantum methods, right? And so the next step is quantum will give us that computational power, but we have to frame the problem in the fashion so that you could use the quantum capabilities there, right? So there are 2 steps. If you look at our the milestones that we have a 2-pronged approach. We want to be making some incremental scientific contribution in our pathways, while at the same time trying to explore these big picture issues that you are mentioning, which is why we mentioned about having these conferences and others to talk about them. So there is a two-pronged approach, and we are conscious of both those pathways as well.
I had a second, more practical question. You listed NSF and a few companies. There clearly are others who would be interested in exploiting this and could be supporters of this activity.
Yes, absolutely. In fact, what has happened is, Yang has mentioned a couple of things. Yang, you want to briefly talk about that?
One of the motivations are in the supervision being endorser of the proposal, also eager to help out on this. So last year, NSF and UIDP, University Industry Development Partnership, organized this workshop in Los Angeles that I recommend the good companies there. That 60 companies come. Many of these are traditional, not necessarily technology companies. These could be customer service companies, and many of them ask a similar question. That is, can quantum computing, quantum algorithm help speed up, for example, logistics or supply chain management? So this is shared with lots of companies. The details may differ, and this is unknown. And actually, they're not, even though quantum computing is a hot area, but there's actually very few institutions actually are partnering with the business school, like in the situation here, to actually attack these problems. Again, there's a lot of research to be done. Many of these answers are known, but there's a tremendous amount of interest. And that is that particular event, which actually led to the report that we drafted together, is led by NSF and UIDP and industry. So this is one motivation that leading to this. So yeah.
Yang, thank you so much. Thank you so much, Karthik.